So what we're learning today is we're learning how to take the derivative of a function or find the derivative of a function or relation without the hassle of doing the full first principles formula. Now, if you don't really like to think about things, then this is right up your alley because it's just a formula. Why does it make sense? Who cares? Or if you do care, go look at first principles. But for us, it's just a formula. So the idea is we can take the derivative, so find the function that describes the slope of another function using this here. Suppose you have function f of x and it's ax to the power of n. To find the function that describes the slope of f of x, all you need to do is you get the power n and you bring it down and multiply it with its coefficient. After, you get the power and you subtract 1 from it. So all you're doing is you're going from here to there. Now, putting this to practice, if we have the function f of x equals 3x to the power of 4, it has a power of what, please, Mia? What's the power?
3. After.
After the
What's the power?
4.
4.
Yeah, but I thought you meant the answer.
What's the coefficient?
3.
What does the power become?
3.
So 4 by 3 is 12.
Yeah.
X to the power of 3.
I wrote 3.
And this is the derivative. How much simpler is that?
I solve every single one.
Makes me happy.
Yeah. Okay, this one, Harrison. What's this going to become?
What, is that 2?
Yeah, it's 2, Harry.
Yeah, 2.
This is it.
2 times
2 times -5.
-5.
2 take 1 plus next one, Dylan.
3 times 1. Then it's 3 take 1.
And then final one,
Just
Leishman. What's this one going to become?
0.
Once more with confidence.
Confidence. Yes.
Okay, so this is -10. X to the power of 1, we don't need the 1 there. 3x squared. And that's the function, this function here describes the slope of f of x at any given value for x.
Mr.
Yes,
4 to the power of 0, which is 1.
whereabouts?
In the last one, when you put 0, wouldn't it be 1? Because 4 to the power of
Yeah, it's already.
We're concerned with the variable x.
If it's just a constant, if it's got an x,
It turns
No,
into
4.
The 4, what about it?
Like, it would, at the moment, it's 4 to the power of 1. You take 1, it's 4 to the power of 0, which anything to the power of 0 is.
Question.
0.
Alright, imagine that this was a x over here, Zoe.
Yeah.
What would this line become? 4 to the power of, 4 times x to the power of 1. What would we multiply 4 by?
1.
1.
Still equals 0.
1 times 4, x to the power of
0.
0, which would be down here, just 4, wouldn't it?
Yeah, so it's 4, not 0.
Now,
It's a constant.
let him cook.
we're going to get rid of the variable x. How does this line have to change? Because I've changed this.
Get rid of the x. I don't know.
What should we do?
Get rid of the x.
Rid of it,
If it's just a constant,
It's just.
you say, bye constant.
yeah.
By constant.
Basically.
Yeah.
Totally piss off.
If you do first principles, you'll notice that it disappears. But it's a really good question, Zoe. Okay, next one. F of x equals 5 over x squared plus 3x to the 7 plus 1. Now, the variables are written in different ways. You don't have to worry about getting this written down now. I promise it won't go away. Only the left hand, no. None of this will go away. You can just watch if you like you're at the cinemas. How are they different? This term and this term, how are their representations different?
One's division and one's times.
One's division, one's times. Now, if we have a look at this rule up here, what one is easier to work with? This form or that form?
Second form.
This form. So what should we write this in?
That form.
That form. Okay.
Oh, so it's just 5x negative 2.
There's a 5. There's going to be an x. What is the consequence of allowing x to come upstairs?
It becomes a negative Nelly.
Becomes a negative Nelly. Did we see that?
Yeah.
Yeah.
The 5 was always upstairs. We just moved the x up there, and it made its exponent negative in its place. Plus 3x to the power of 7 plus 1. This, have we started taking the derivative? No. It's still f of x. Now let's take the derivative. We have a coefficient of 5, we have a power of -2. What will this first line turn into?
-2 times 5x negative to the power of -2 minus 1.
Bingo. Next one?
7 times 3x power of 7 minus 1.
And then
Negative 7.
And the 1 can just like piss.
-7.
Yeah.
And then, what do we say to the constant?
Go
0.
away.
Wave and say, bye constant. Okay, so this becomes -10x, take 3, plus, you don't need the plus, sorry. If we were doing this by first principles, how long do you reckon that would take?
Too long.
Exactly what I was thinking.
Yeah.
You wouldn't do that at stage 1 level first principles. Okay, now, there's 2 more. Now, I was talking about Leibniz notation earlier. These are all functions. These functions could also be written as relation form. If we wanted to take the derivative here, how would we write this? We could do y prime. We could also say d over dx. Yeah, d over dx. Or we could also write dy over dx. The d's mean change in. In other areas they use triangle, so delta to mean change in. In calculus we use d for change. So this means the rate at which y is changing with respect to the rate at which x is changing. And then we simply take the derivative here. So it's going to be -1 times 3x, -1, take 1, plus 0.
So the dy.
I've done it.
dy over dx, are we okay with that?
Yeah.
You slowly familiarize yourself with all these different ways in which we write derivative. You can have the d over dy all the way to the left, which means something a little bit less processed than dy over dx. In terms of methods, there's no difference for us. It's all the same. All right, now, I've been talking a lot. This final one, find the slope of y equals -3x squared plus 2 at the value of x equals 4. Oops. The question is, do we have some sort of tool to find the slope of a relation at any given value of x? Is there some sort of math we can use to find the slope of this function here for any given value of x? What is it?
I don't know. How does my letter?
Desmos.
Desmos?
What's the purpose of what we've been doing?
Decent power. Differentiate.
Yeah, the derivative, taking the derivative allows us to find the function that describes the slope of its original function at any given value of x. So, what should we do to this function here to find the slope at x equals 4,
Do what we did up there.
which is called the,
Simple power.
take the,
Take
Derivative.
the
bingo, take the derivative. do you want to use first principles or do you want to use simple power rule?
Simple
Simple
power.
power.
Simple power rule unless the question asks otherwise. If what, this one's even worse. If y is equal to minus 3x squared plus 2, then the change of y with respect to the change in x is going to be 2 times minus 3 x squared plus 0 with the take 1 on there. Almost made a mistake. Okay, I'll process this a little bit more. dy over dx minus 6 x to the 1. So I don't need that there. Cool. Now what's the slope going to be? This describes the function, or sorry, this relation here describes the slope of this relation. How can we find the slope at x equals 4?
Just put like a plus x equal.
Yeah, absolutely. We can, finding slope, I'm going to say dy over dx. Now you don't have to add this little bit of flair here, but you can if you want to be really explicit. I get a pipe, all right, x equals 4. And then every time I see x, I substitute in 4. So 6 4s are 24. What's the slope when x equals 4? It's got a slope of 24. So the tangent, which is y equals minus 3x squared plus 4.
Plus 2.
Oh, plus 2. Okay. I'll just do that. All right. We're looking for an x value of 4, are we not? Okay, when x equals 4, our y is going to be minus 46. So assume that out a little bit. So that's our value there. We're looking for the derivative, so m is going to be minus 24. Do we follow? Don't worry, this is a lot of crap on the screen. Just focus on the picture. And that gradient is going to be, why is that in the wrong place? That should be touching there. Oh, because it's not working properly. Oh, here it is. Ignore that green line. Okay, so can we all see this? So the red line's our tangent. Do you remember what a tangent is? It's a line that touches another line in a singular point only, and it's hitting at 90 degrees. Okay, so this is our line, it's calculated fine. You see how this is moving?
Yeah.
This red line shows the slope of the blue line, but it's showing it in the form of a tangent at any given value. Does this make sense, guys?
Yes.
Does what happened on the board, could you do that under guidance?
Draw that.
Not this, sorry, that board. Could you do that math?
Super
Yeah, but
parallel.
I just don't understand.
Yeah.
That's coming. This is just the application.
That's fucked up.
Sorry, no, it's actually method stuff, the next lesson. Sorry, I went too far. Would you guys be okay with this stuff here, the simple power rule?
Yes.
Yeah.
Yes.
What about all the way down here if we're picking a point?
I feel like it.
Yeah, so I didn't want to just
Yeah.
leave this and just say, oh, here's some stuff. There's no application to it. I just wanted to show you what it did. Could you do that?
Yes.
So you'd be fine doing this.
Yeah.
No.
No.
Okay, so what we have planned for today, guys.